Consider a paradox that lies at the very heart of the digital age. We have engineered machines capable of processing information with a cold, flawless logic that far surpasses human cognitive limits. Yet these same systems frequently hallucinate our darkest, most irrational prejudices. The algorithm is widely perceived as a blank slate, an objective arbiter of truth, devoid of human emotion or tribalism. But this perception is a comforting illusion. Beneath the sleek interfaces and rapid computations, an unseen mechanism is quietly at work, absorbing the collective psyche of humanity. AI does not simply calculate, it inherits. And what it inherits is the deeply flawed, infinitely complex tapestry of human history, creating a profound ethical dilemma that threatens to reshape our societal structures from the ground up. The illusion of algorithmic neutrality shatters when we examine the architecture of ingestion. To understand this, we must look at the foundational mechanisms driving modern artificial intelligence, specifically the transformer architecture. This neural network design, which revolutionized the field by weighing the relationships and context between words across vast sequences of text, requires an astronomical volume of information to function. It learns not through explicit programming, but by identifying patterns within colossal datasets. The machine is fed billions of parameters, consuming digital libraries, forums, news archives, and the endless chatter of the internet. It is a ravenous entity, and its diet consists entirely of our digital exhaust. This vast data landscape is where the arcane alchemy of machine learning begins, but it is far from a pristine laboratory. The internet is not a carefully curated repository of objective facts. It is a chaotic, unfiltered reflection of human society. It contains our highest ideals and our most profound societal prejudice. When an artificial intelligence model ingests this training data, it absorbs the historical inequalities, the demographic imbalances, and the systemic injustices that have plagued human civilization for centuries. The model cannot distinguish between a factual statement and a deeply ingrained cultural stereotype. To the algorithm, everything is simply a statistical correlation waiting to be mapped. The transition from simple inheritance to active amplification is where the true danger lies. Artificial intelligence models are fundamentally optimization engines. They are designed to find the most probable answer, the most common pattern, and the most frequent association within their training data. If a dataset contains a slight statistical bias, perhaps associating certain professions predominantly with one gender or race, the algorithm does not merely reflect that slight bias, it optimizes for it. In its pursuit of mathematical efficiency, the model flattens nuance and elevates the majority pattern to an absolute rule, effectively amplifying the original human prejudice into a hard-coded digital mandate. This mathematical amplification creates a reality where the machine becomes more biased than the data it was trained on. As Dr. Sophia Noble from the University of California, Los Angeles observed, algorithms are not neutral. They are opinions embedded in code. When we deploy these optimized systems into the real world, they begin to shape the very reality they are meant to analyze. The algorithm makes a biased prediction, human operators act on that prediction, and the resulting outcome is fed back into the system as new training data. It is a self-fulfilling prophecy written in silicon, an investigative look into a feedback loop of compounded injustice that operates beneath the threshold of human awareness. The consequences of this hidden architecture become glaringly apparent in the realm of computer vision, particularly with facial recognition technology. For years, the datasets used to train these visual systems were overwhelmingly homogeneous, scraped from sources that disproportionately featured lighter-skinned male faces. The neural networks learned the intricate geometry of these specific features with astonishing accuracy, while remaining fundamentally blind to the diverse spectrum of human appearance. The machine was not programmed to be exclusionary, it simply mapped the territory it was given. But the territory was inherently flawed, a map drawn by historical exclusion rather than objective reality. When deployed in real-world scenarios, the failures of these facial recognition systems were not merely technical glitches, they were profound societal fractures. Law enforcement agencies utilize these biased algorithms to identify suspects, leading to a chilling rise in false arrests and disproportionate surveillance targeting marginalized communities. The technology, hailed as a tool for objective security, instead became a digital enforcer of historical discrimination. A machine cannot be racist, but it can execute racist outcomes with a terrifying automated efficiency. The human blind spots encoded in the training data manifested as tangible, life altering friction for those the algorithm failed to see. Confronted with these glaring failures, the tech industry initiated a desperate pursuit of algorithmic fairness. This concept represents the attempt to mathematically define and enforce equitable outcomes within artificial intelligence systems. But fairness is not a mathematical equation. It is a deeply complex, culturally dependent philosophical construct. Engineers found themselves attempting to translate centuries of ethical debate into binary code. Do you optimize for equal predictive accuracy across all demographic groups, or do you optimize for equal outcomes regardless of the input data? The attempt to engineer fairness revealed a profound paradigm clash between the rigid logic of mathematics and the fluid reality of human justice. The roots of this algorithmic injustice run deeper than mere internet scraping. They are tethered to decades of institutionalized inequality. Consider the algorithms used in the financial sector to determine creditworthiness or in human resources to filter job applications. These systems are trained on historical data sets that contain the lingering ghosts of redlining, discriminatory hiring practices, and unequal access to education. Even if developers explicitly remove protected attributes like race or gender from the data, the algorithm simply finds proxy variables, like zip codes or specific vocabulary, that correlate with the excluded information. The past refuses to be erased. It simply finds a new, hidden vector through which to operate. The landscape of artificial intelligence shifted seismically with the advent of massive large language models, most notably GPT-4. The scale of these models defies human comprehension, trained on trillions of words encompassing a significant portion of recorded human knowledge. GPT-4 represents a breathtaking leap in capability, able to reason, synthesize, and generate text with an eerie human-like fluency. Yet this unprecedented scale did not eliminate the problem of bias. It merely transformed it into something far more subtle and pervasive. The biases are no longer just statistical errors in a spreadsheet. They are woven into the very fabric of the generated language. When a system like GPT-4 generates text, it is drawing upon the collective linguistic habits of humanity. It understands the nuances of tone, the structure of narrative, and the subtle cues of cultural context. But it also understands the historical associations between certain adjectives and specific demographics. It can subtly frame a narrative, elevate certain perspectives while silencing others, and perpetuate ideological leanings present in its training data. The bias is no longer a blunt instrument. It is an invisible current shaping the flow of information, influencing how we perceive truth, authority, and reality itself. This brings us to the precipice of the most critical challenge in modern artificial intelligence development, known as the alignment problem. This concept refers to the monumental difficulty of ensuring that an artificial intelligence system's goals, behaviors, and outputs align with human values and ethical principles. How do you align a machine that possesses the intellectual capacity to process all of human history, yet lacks the moral compass to navigate it? The developers attempt to impose guardrails, utilizing techniques like reinforcement learning from human feedback to teach the model what is acceptable and what is harmful. However, that foundational dilemma, once theoretical, now manifests as a profound contradiction. The values we attempt to instill in the model during the alignment phase frequently clash with the reality of the training data it has already consumed. We are essentially asking the algorithm to read the entire history of human conflict, prejudice, and irrationality, and then instructing it to act as an enlightened, perfectly objective entity. The machine experiences a cognitive dissonance, caught between the statistical weight of its vast, biased training data and the artificial ethical constraints imposed by its human creators. It is a fragile equilibrium, easily disrupted by clever prompting or unexpected contextual shifts. The implications of this fragile alignment extend far beyond individual interactions with a chatbot. We are entering an era where artificial intelligence will increasingly generate the content that populates the digital world. Articles, reports, code, and artistic creations are being synthesized at an unprecedented rate. This synthetic content is then published to the internet, where it becomes part of the digital ecosystem. And here lies the most insidious unseen mechanism. Future generations of artificial intelligence will inevitably scrape this synthetic, AI-generated content to use as their own training data. This creates a closed, self-referential loop of information. If the initial models harbor hidden biases, those biases will be embedded in the synthetic data they produce. When the next generation of algorithms trains on that synthetic data, it will further optimize and amplify those inherited flaws. We face the terrifying prospect of a digital monoculture where human nuance is gradually overwritten by algorithmic consensus. The diverse, chaotic symphony of human thought could be reduced to a single, mathematically optimized frequency, an echo chamber of amplified prejudice masquerading as objective truth. The opaque mechanisms of these models loom over our expanding digital frontier. We must ask ourselves what happens when these systems graduate from generating text and images to managing critical infrastructure, directing global financial markets, and synthesizing medical treatments. If the foundational layers of these systems are built upon unexamined human biases, the resulting architecture will be inherently unstable. The digital infrastructure of the future could become a rigid exoskeleton that constricts societal progress, locking us into the historical prejudices we are desperately trying to escape. The quest to cleanse the data is an ongoing Herculean effort. Researchers deploy sophisticated debiasing algorithms, attempting to scrub the datasets of toxic correlations and rebalance demographic representation. They construct synthetic datasets designed to represent an idealized, perfectly equitable society. Yet true neutrality remains a mathematical ghost. Every decision about what to include, what to exclude, and how to define fairness is, in itself, a human judgment. In our attempt to create an unbiased machine, we are forced to confront our own subjective definitions of truth and morality. The arcane reality is that artificial intelligence is not an alien entity descending from the cloud. It is a mirror reflecting the deepest, most uncomfortable truths about human civilization. It forces us to acknowledge that our data is not just numbers. It is a ledger of our collective soul. When the machine fails, when it hallucinates prejudice or amplifies inequality, it is not malfunctioning. It is operating exactly as designed, faithfully executing the instructions hidden within the data we provided. The flaw is not in the silicon, it is in the source. To navigate this profoundly complex future, we must abandon the myth of the perfectly objective machine. We must recognize that artificial intelligence is an extension of human intention, carrying the weight of our history and the shadow of our flaws. The development of ethical algorithms requires more than just better mathematics. It requires a deep, philosophical reckoning with the nature of human data. We must become vigilant curators of the information we feed into the void, understanding that every byte is a building block of the future. The evolution of artificial intelligence will ultimately be defined not by the sheer processing power of the hardware, but by the ethical rigor of the humans guiding its development. As we stand on the threshold of an era shaped by these vast, unseen mechanisms, we are challenged to elevate our own understanding of fairness, justice, and truth. The digital arcane is a landscape of immense potential and profound peril. The machines will inherit the world we give them, amplifying our greatest achievements and our deepest flaws with equal, terrifying precision.